Hey, I got the right answers. Give me a second. What? I would never check my answers on previous. Okay, yeah, I got the right answers. Cool. Okay, let's go do step assignment 7. Hello everyone, I'm Lazen Lai. I literally just ended the assignment 6 stream 5 minutes ago. Now, you notice we're doing a bit of a different format. We are doing a very short micro streams, and in between the streams, I'm kind of going outside, taking a break, getting a bit of fresh air, and then I'm coming back and doing the next one. So hopefully, this is gonna increase our problem-solving ability that much more. And seeing how efficient this is, I might actually go ahead and open up a few more lovely. I forgot what the word was. A few more step assignments. Yes, that's it. So, I reckon we could get at least like through these, right? I reckon we could get 8. We could definitely get 10. I don't know if we could get through 10 actually, but we will try. We will try. I'd say the worst ones are definitely the later ones that require you to do a lot of differentiation. It's kind of a lot of calculus. But let's ignore that for now. Actually, let's ignore these for now too. They're not that important. We don't need to look at them yet. Let's just go and handle assignment 7 first. Let's not get over our heads. So, sketch on different axes, right? Sketch on different axes the graphs of this and that. So we can do this by combining graphs. Oh. So the way that we want to draw the merge together graph is looking kind of like this. Yeah, so this basically becomes y equals x as x goes to infinity, so this is pretty much what we can draw. Yeah. Okay, great. So let's go do, oh no, I forgot. We have to do ooh, do we also have to do the other side? Yeah, we do, don't we? Yeah, so it's probably gonna have to stay. Okay, actually, let's redraw this graph then. It's a bit ugly. You can tell I'm actually making an effort to draw straight lines now. So it looks something like this. This. Paying particular attention to turning points. So we can differentiate this. That's 1 plus. Actually 1 minus. 1 minus. This. That seems about right. Now we can tell that for 0, it's this, which means Yeah, and there are no places where it crosses the x-axis or y-axis. Yeah. So now let's do. I guess it's still the same question. So let's just draw the graph and not worry about it too much. So always it's important to label the axes. And now we're doing that, which is just gonna be flipped. So it's gonna look something like this. Oh, sorry. So it's gonna look like this. Yeah. And so this time there are in fact no turning points, I don't believe. But there are intercepts, so let's go figure those out. And that's it. So, with that concluded, let's go do I. Well, for what values of x is this? Now, of course, we can use the solutions to part I to solve part II. So, let's simply draw a lovely graph. And I missed a straight line. Okay, whatever. The point is, there's a line here. Good enough. And this is y equals 0, y equals 2, and so you can see that as long as it is above x, it is above 0, actually, this is true. It is bigger than 2, so great, let's write that down. Larger than. There's gonna be 2 points here. So let's just write it like this. Now we're in a bit of conundrum because we can't multiply by x, because that would fuck up the inequality. So we can multiply by x squared. So that is a bit of a problem. Oh no, it's not. No, it actually delivers us quite a clean solution. This we can solve. So this this becomes x minus 2, 2x plus 1, x. That means there are 3 values, that means the corresponding thing. And we know sure as hell it's not gonna be 0, right? Yeah, no, because that fucks it up, obviously. So it's not gonna be 0, but it is gonna be 2, and it is going to be minus this and x. Yeah, so this is one of them. This is the other. Now let's do ooh. Okay, so this is horrible. It's long and it's horrible and it's gonna take forever. Might be fun to do the one down first, actually, but ignoring that, let's go do the preparation, I guess. So one of the most difficult things for first-year university students is trying to find a proof of something that seems very obvious. The key is always to go back to the definitions. In university mathematics, we always start with definitions, and any statement of freedom has to be proved using those definitions. In this question, forget that you know how to solve a quadratic equation. It may seem strange that we are asking you to forget, for the moment, something that everyone else is trying to make you remember, but the idea is to come up with methods that could be extended to more complicated equations. Show that if alpha and beta, where alpha is not equal to beta, both satisfy the quadratic equation, then b is equal to negative alpha plus beta. Find an expression for C in terms of alpha and beta. Simultaneous equations do look a bit complicated, but can be solved with standard methods. Hence, show that that mess equals that mess. Note that the triple bracket means identity, which we already know. Okay, so let's have a go at it. Now, perhaps we'll just write this first. So we've got this. Which I suppose we could actually use to solve C first, which is quite funny. We can get rid of the negatives, because they annoy me. Oop. So yeah, now we found an expression for C. Oh, great. Yeah, through some simple algebraic manipulation with Z and C. Now B. Now I suppose we could just sub it in. means that B equals this. Yeah, easy. And now we can show that this which directly translates into x plus 3 plus 2. Great. So we've solved that. Let's look at I. Given that this equals this, substitute 0 into both sides and hence show that alpha and beta equals C. It can't be done. C. Shocking. Substitute 1. Wait. This is B, isn't it? Oh, this is B. Oopsie doopsie. There's a 1 here missing. Oh my days. Let's make C cancel. Oh, so this value equals 0. Okay. So write down two positive integers, alpha and beta, such that alpha and beta added together equals 10. Honestly, I feel like I'm not challenging myself enough. Let's add a bit of challenge, right? Let's make this fun and interesting. What's the time right now? It's 20 minutes. I've spent 20 minutes and I haven't really learned that much, right? I've just been doing a bunch of maths. But none of this has really been all that challenging. So let's set ourselves a challenge. I have to finish this within 25 minutes. Actually, let's say half an hour, right? Half an hour. Or else, I don't know, I'll do something. What's a good punishment? Um, let's see. Or else, no dinner isn't really the kind of thing that I do. Like, I'll just sit there and keep working and eventually faint, which isn't all that productive. I can't really think of a punishment. Yeah. I guess I won't allow myself to look on my phone. Like, usually I like to do a bit of reading on my phone. I guess I'll ban that for myself today if I don't finish this in half an hour. So, I've set a timer for myself and go. Okay, so take this seriously. Write down two positive integers alpha and beta such that alpha beta equals 10 and alpha plus beta equals 7. This should be easy. Yeah, so alpha equals 2, beta equals 5, and so therefore the roots of the equation are just that, right? Yeah, cool. Okay, so that's fairly obvious. Sometimes the results are obvious and sometimes they're startling. For example, the Rose theorem states that if fa equals 0 and fb equals 0, then f of x has a turning point between a and b. Very obvious. If f of x didn't have a turning point, it couldn't get back to 0. But it still has to be proved, starting from the definition of a differentiable function. A Starling theorem is the theorem Banach-Tarski, which shows, starting from some pretty harmless definitions, you can cut a solid sphere into several pieces, then put them back together to form a smaller solid sphere. Of course, the cuts have to be very peculiar. Good for you. Not relevant, but good for you. It is given that there is a cubic with three roots, and by substituting three values of x, show that, of course, this. Hmm. Oh, so you're generalizing it. Okay. So, we have to show that this equals this. Let's see. So the obvious one is x equals 0. Then that means multiplying all of this together becomes the first one. And the second result is that we plug 1 in. So x equals 1 is the second result, which I'm not going to write out because I'm on the time limit. And I suspect the second one is also fairly obvious. Yep, it's x equals negative 1. Actually, no, we'll write this one out because it is a bit confusing, so may as well. So, okay, so that's our result. And let's see, we can take the x's out of all of these, and then we can take the x's out of all of these and turn them into this lovely looking thing. Now there's negative, and then the negative goes over here, and it becomes 1. Negative this. Yeah. So that's our answer, and that's that. So let's look at V. Given that this is fun. Given that we have this funky little equation using one of the equations from part IV, this is that. Hmm. Omoshiroi. Oh, so we're using the third equation, and we can just take 1 minus b uh, plus c. Wait, I did this wrong. Minus 16, which equals minus 15. Yeah, which is therefore equal to that. Okay, what are the eight possible values? Oh my days, that's a lot of things to do. Okay, calm down. What are the eight possible values of alpha? We know that these are integers. What are the factors of 15? We've got 1, we've got 15, we've got 3, we've got 5. And then obviously all of these can be negative. So that means alpha can be, okay, alpha can be 0, it can be 14, it can be 2, it can be 4, or it can be -2, -16, -4, or -6, because that's how you can get 1 plus alpha to equal these order negatives. Okay, write down the value of alpha and beta and whatchamacallit, which is this, right? That's just D, which also happens to be equivalent to this. Negative D, I guess. Which of the A values can you now eliminate? We are eliminating this, yeah, so just do O and this. Yeah, okay. Now use the remaining equation from part IV to eliminate the rest of the options. Okay. So 1 minus this plus this is of course equals to 9. So that means our 1 plus alpha and so on and so such have to multiply into 9, which should cross a couple of these out. Oh yeah, crosses 4 out, because 4 plus 1 equals 5, and 5 doesn't multiply to that. Crosses this out, obviously. So now our remainders are 3, -3, and -1, which makes sense, yeah. So alpha could be 2, -2, or -4. Or in other words, 3, -1, -3. Hence find the values. Oh hey, these 3 happen to multiply together to become 9. Oh yeah, because of that. Okay, so that means that, let's see. Alpha is the smallest. Alpha equals -3, beta equals -2, and our lovely symbol that I don't know the name for is 2. Great, okay. How far behind are we? I know that took a while. Okay, that only took 8 minutes. I'm fine with that. I'm fine with that. I'm fine with that. Let's go. Step question. Let step be step, where a and 2 and a and n are such numbers. It's given that f of x can be written in the form f of x equals to this. By considering f0 or otherwise, show that this equals that. So if f of x equals 0, then it becomes k1, k2, well, yeah, because of, this. So on and so forth. And so that is just k1, k2, k3, and then kn, which equals an. Yeah. Okay. Show also that k1 plus 1. Okay, so basically the exact same thing. F of 1, k1 plus 1, 2 plus 1, so forth, is equals to 1 plus a1 times 1, negative 1, say 2, 1, negative 2, and so forth until you reach an, which means that this is just a an. which is a lot of writing. I'm not a fan of it. Done. And give a corresponding result. Oh my days. Okay. But Jesus. Right. So then this becomes K1. It's 1 K2 minus 1, and so on and so forth. I'm not writing them all out. Okay, now this is the interesting part. So AN stays normal. Actually, no, let's just go with this. So this becomes -1. N. Yeah. So this becomes -1 n minus 1 times A1, so on and so forth until you reach AN, which remains normal. Yeah, okay. Oh, that's it. So find the roots of the equation given that they are all integers. Oh, fuck. So that's the step question. Okay, so that's the hard part. I see. Okay, so we need to know that this is four roots, which means there's K1, K2, K3, K4. And these all equal, of course, 576. Clue number one. Clue number two. Of course, is that 1 plus 22 plus this, and also plus this equals to that, and so forth. I'm not writing them all out. And so we can add all of this together. Last digit is 2. Then it's 20, 22? Well, I think it's 22. Give me a second. So, okay, carry the 1. That's 25 plus 7. Yeah, okay, it's 22. And then there's carry 2 with. Okay, so that's that. That's the answer. Wonderful. And then let's see. Okay, let's recall how we figured out the question over here. Okay, so bit of a time loss, but we still got 15 minutes plus the warm up. Now we're writing same thing. Okay, so that's that. So this definitely has fewer factors. This is just 5, 2. And then one of them is 7? 7. Yeah. And then this is, let's see, this is 666? No, 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 661. Yeah, 661. So 661, then 661 is very hard to split apart, but we'll try. It's not 3, it's not 5, it's not, it could be 7. Could, nah, no chance. It's not 7. It's not 9. It's, could be 11. No, it's not 11. Could it be 14? No, it's not 14. Could it be 17? Unlikely. No, it's not 17. Is it 19? Um, hmm. Actually, 19. So 19, 15. No, 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 57. 57. That means 91 left over. Ooh, promising. What was it? 19? No. No, no. On second thought. Nah. Nah. It's not 19, it's 21. 21's what am I talking about? 23? Could be. 3, 1. It's not 23, it's. You gotta be able to split this one apart, right? It's just gotta be possible. It's not 21, it's not 23. Okay, you know what? I give up on this one. Let's go look at this one, right? This one seems easier. 5. The 2, 5. Oh Lord. Oh, actually, it's not 2, 5. I'm on about. It's 2, 8. Yeah, 2, 8, 8. 2, 8, 8. 1, 4, 4. 7, 2, 16. And then this reduces into. So yeah, 2, 1, 2, 3, 4, 5, 6, 7. So 2 to the power of 7. That's 3 to the power of 2. Which is again impossible to figure out, but we will persevere. So, hmm. Again, how do we solve the previous one? It was using this method where we figured them out. Yeah, we figured out all of the possible values that alpha could be. Yeah, okay. So, let's write that K1 could be equal to 5, 25. It could be even equal to 35, 1, 7. And I guess all of these multiply together, which is 75. Should be all the combos. So, oh wait, no. So this is K1 minus 1. So that means it's more looking like 6, 26, 36, 2, 876. And so that means we should be able to disregard a couple of these. Being this one, obviously this one. So that leaves us with 4 options. And 4 options just so happen to be what we have. So, yeah, wondrously enough, 4 options is what we have. So, this is 2 to the power of 7, which means that our answers are 8, So yeah, it's roots are therefore, first of all, 36. Actually, wait. No, wait. Okay, no, no, no. Let's think about this again. Let's separate this into 2x3. This is 2x2 times 2x3. So either it's 36 2 8, or it is 6 6 8 2. No, that doesn't add. So it has to be this. Interesting. Okay, yeah, we'll take it like that. Okay, so that means, yeah, okay, it has to be that then. Okay, so let's try adding these then, I guess. I don't know. 5 times 8 does not add together to be that. Okay, that's a problem. Let's do this more systematically. I mean, it's already pretty systematic though. I don't know what we could improve necessarily. Okay, so let's go back to work. So we can cross out 26 and 176 because these were just obviously incorrect. You can't plug them into here at all. Actually, can you? Let's see. This is 80, 88. It's 11. Yeah, no, it doesn't plug. Yeah, that cannot be plugged in, and that's a factor. One of its factors 14, which is even worse. So that means that these are only available options, and the only combination I can think of that has two threes and seven twos is 36. Two, and then eight. Two, and then eight. But then these simply do not add together to form a result. And I'm pretty sure we've already crossed the time. Oh no, we have 5 minutes. So maybe I need to double check my adding. That could be it. I mean, I'm not the most accomplished of adders. No, it seems correct. And then this one is. We haven't even looked at this one yet, so why bother? Uh huh. Okay, let's just try out 36 to 2 and 6. You know what? Why not? So 36 times 6 is 36 times 6 is 2 this, and then this, which means 4 times, so 864, which is obviously out of bounds. So, God, I don't know. This is a tough question. I mean, it's not a tough question. They've given us the method practically on a plate. But I don't quite know where the plugin point is. Makes this possible. I think I've probably made a stupid mistake somewhere down the line. There always is that. Okay, let's look at the factoring of this again then. Factor this 38 times 2 is in fact that. Then you got this, you divide that, divide it again, you divide it again, you divide it again, you divide it again. Okay, again. 1, 2, 3, 4, 5, 6, 7. 7. 7 twos. That's right. Das ist korrekt. I'm out of time. Oh, I've got a minute left. I could guess, but I'd still be wrong, so does not matter. Wait, I've got it. One of these has to be negative. Oh, yeah. Because otherwise, how could it be zero? Yeah, I'm a complete dumbass. I forgot about the negatives. Yeah, in which case, you get a lot more options, don't ya? Like, you got negative. Oh, okay. So let's see. You got -5. I think that's an option. Yeah, you got -5. You got -25. You got -35. You got -1, -7, -150, whatever. And then this actually becomes, since you're minusing one, or you're adding one actually. You're adding one. So this becomes this. That's a whole new world for us to work with. This just becomes 0. This becomes 6. This becomes 174. Lovely. Oh, whole new solutions. Okay, so now let's begin crossing out some of these, like fucking obviously, this is not gonna work, it's not gonna work, it's not gonna work. So now we've got a few more options available to us. Yeah, so now we really need to factor this. Yeah, now there's no getting around it. We need to factor this. I mean, at least one of these has to be a factor, right? Oh, wait, we need to transform all of these. Ah, damn. Okay, so give me a second. So we need to add 2 to all of these or add 1. Okay, no, we need to add 1 to all of these. So this becomes this. Yeah, okay. So let me just erase all of this. This was all wrong and irrelevant. So, let's make the oop. Let's make this into K. Whoop. K1. This is K1 plus 1. So therefore, this is 7. This is 37. This is 3. This is 9. This is negative 3. This is negative 25. And since we know that most of these are going to be pretty irrelevant, it's probably 47 that is the factor. So this minus this is just, is it 79? Is it 79? I'm pretty sure it's 79. 79 has fuck all to do with 37. Great! Back to square one. Really? Are we sure that I haven't done some kind of arithmetic error here? He's not half. I forgot the one. It's annoying. 15 to. Great. That's the correct answer. Great. Excellent, in fact. Excellent. This divides by 7. Oh my days. Yeah, this divides by 7. So since this divides by 7, it's here's graph from 140 1400. So this is it 9? No, not yet. It's not 9. It's 89. Yeah, it's 189. And that properly divides by something else, divides by 3, so it is 63. 63 divides again. So it's 7, 2. And then it is simply 3, 3, 3. So 3 cubed. So 3 cubed is how to factor that. So that's factor. That's a thing. Okay. So we've already crossed this out. And now we need to start crossing this out. This doesn't fit. This doesn't fit. This very obviously does not fit. Now you're left with 4 solutions. So K1, fuck it, roots are 7, 3, 9, negative 3. And I'm sure I could prove it with a calculator, but I can't be arsed. Finally! Oh, okay. We are out of time, which is unfortunate. But let's go do the warm up and let's go get that done quick. If I can only put the weights in one of the scale pans, show that I can choose just 3 weights to measure all of the. Okay, start from the beginning. I have a set of scales. If I can put the weights in one of the scale pans, 3 weights can measure all the integer number of answers from 1 to 7. Okay, that's quite interesting. So 1 has to be one of them because you have to measure 1 ounce. And they have to add up together to 7 because 7 is the largest that you can measure. Oh, this is just binary. Yeah. Okay, so binary, 1, 2, 4, and now you have to show that as only one such choice. Okay. There are many numbers to add together to 7. You can't go that route. Hmm. Okay, so let's go case by case, right? Run must be a weight to measure one ounce, right? Two must be a weight to measure two free. Four must be a weight measure four, five, six, seven. Place any scales fail. Find 5 ounces, no explaining, lovely. Which enable me to weigh out all of the integer number of ounces from 1 ounce to 31 ounces. Ideal, but of course. One, two, four, 8, 16, done. Okay, next question. C. Should I have only n weights, I cannot weigh more than 2n different weights. Oh, so it's a binary question. Okay. Hint, each weight is either in the pan or not in the pan. How can I choose weights in order to measure all the integer number of ounces from 1 ounce to 2 to the n minus 1 ounces? To answer the second part first, which is choose weights in geometric series 1, 2, 4, a, and so on to this. Right, so we already know that's the correct answer, but show that if I have only n weights, I cannot weigh more than 2n different weights, including 0 ounces. Yeah, okay. So let's just write out the first question. Each weight is in pan or not in pan, which means that for each weight, there are two options. The possible combinations of weights assuming each combo is unique, is 2 to the n. Show that shit though. Okay, actually, no. I should probably explain this a little more. So, let's see. Um, take one weight. It is in or out, creating 2 combos. Take next weight is also in out. 4 combos. Total 2x2. Doubles. Possible combinations. Yeah, good enough. Whatever. I don't want to do a damage rating. Let's just go do II. I'm like, I just don't care anymore. Let's go do II. So, if I can put the weights in either of the scale pans, which 2 weights do I need if I wish to be able to weigh 1 ounce, 2 ounces, 3 ounces, and 4 ounces? One and 3. Well, again, it's fairly obvious. So if you want to weigh 1 ounce, just put a. If you want to put a 1, just put a 1. If you want to weigh 3, just put a 3. If you want to weigh 4, then put the 1 and 3 on one side. If you want to weigh a 2, then put 3 on one side and 1 on one side. And so let's look at B. Should if I have only n weights, I cannot weigh more than 3n different weights, or 3 to the power of n different weights. Find 4, okay, let's do C first, because that one's guaranteed to be easier. Find 4 weights which enable me to measure all of the integer number of ounces from 1 ounce to 40 ounces. Great. So they all have to sum together to 40. We know that. So, of course, it's just, again, a simple combination. It's 1, 3, 9, and 27. They all sum together to 40, and it follows the same kind of pattern that we've already seen here with 1 and 3. Short of only n weights, I can weigh more than 2 ounces. Again, each weigh 3 options. Left, right, or out. That means each weight triples number of combinations. Therefore, n weights equals 3n combinations if each combo unique combo is just equal to weight. Done. Yay. Okay, so that is this assignment done. And because I'm a lazy bastard, I'm gonna end the video right here. Thank you everyone for watching. It took 44 minutes. On stream time was, in fact, an hour, which is less than ideal, I guess, for it to take an hour, but I'm pretty happy with our progress, and I suppose I will do 1 or 2 more streams in order to kind of race through the rest of this content. Because let's be honest, this is not the hardest stuff that Step has to offer, and I want to get to the hard bit so we can start struggling.